Hi, high school chemistry teachers. I'm Kendra, creator of ChemEd Solutions, and it's my mission to change the narrative of high school chemistry from yuck to yay by designing student and teacher materials that allow you to focus on what mattered most, getting all of your students to be confident and successful without the burden of using your personal time to do so. I support you by giving you my best proven tips vetted by thousands of students, parents, and case managers. So today's tip is on color blocking orbitals. This is from our unit on the atom. When I teach color blocking orbitals, I have my students utilize their periodic table as a tool, especially when determining the electron configurations of an atom. I find that students, prior to me instructing them to use their periodic table as a tool, simply think the periodic table is just a collection of elements. I have my students use a paper periodic table, and by the end of the semester and the year, it is full of color, highlighter, pen, pencil, and notes for them to see just how much information can be pulled from it. When teaching electron configurations, I have my students color block their periodic table. I have them color block orbitals and then number energy levels on the periodic table to create an easy visual. I talk about orbitals, and I tell them first that they're going to move their box for helium over to the left-hand side in group 2. I then have them outline and shade the s orbitals, groups 1 and 2, and then from there, we talk about the p orbitals. Our p orbitals are going to be groups 3 through 8, so I have them outline and shade those in. Then I have them do the d orbitals, which are your transition metals. And then the f orbital, which is the inner transition metals. Again, outline and color in. I have them do this in class, and I walk around making sure that they're doing it correctly. Once everybody has their blocks colored in, then we talk about energy levels. I have them number the energy levels of each orbital. I tell them that S is the lowest energy orbital, therefore we start numbering our rows of the periodic table with 1. Numbering it 1 and continuing down. The p orbital is the next higher energy orbital, therefore we begin numbering it with 2. I have them write a 2 next to boron and continuing numbering down rows of the block. The d orbital is the next higher energy level, therefore it begins with energy level 3. I have them write a 3 next to scandium and continue numbering down. And then the f orbital is the highest, therefore it begins with energy level 4, and have them write a 4 next to La and a 5 next to Az. From here, I teach my students to read electron configurations by first finding the element in question, then going back to the beginning, hydrogen, and using their fingers like when they were learning to read, following along the rows and reporting electron configurations at the end of the block. In class, I teach the first 15 of them together, and then we begin to jump further down. I have them recite them together, and it almost sounds like a cult with a chant, but they start to really get the feel of what this looks like, and then they're able to do it really quickly on their own. One of the biggest areas to have them watch out for is in the 4th row of the periodic table. We have 4s2, and then we jump to 3d, and then back to 4 for p. I also like to have my students highlight this 3 just as a reminder for them, so that way they don't become complacent when they're reading left to right. So then I would have my students practice. So going to find vanadium. Vanadium is located right here as the 3rd element in row 3 of the D block. So I have them start at the beginning. I'd say 1s2, because there's 2 elements across. The end is 2. And then we can't continue off. And so we go to the next one, 2s2. I also have them draw arrows coming across so they know where to go. So to here. And then 2p6, have them come back, 3s2. Again, I draw the arrow across, 3p6. Then they come to 4s2. Again, this 3 is highlighted as a reminder, hey, there's a 3 here and it's supposed to be here. And 3d, and the vanadium's the 3rd one over. 1, 2, 3. So 3d3. Again, I like to remind them that when they're doing this, that it's big first number, lowercase second. We don't use cursive, and then the superscript, and no extra punctuation in these. To never miss a weekly teacher toolkit tip and get access to my PDF copy of both this teacher and also a student version of this tip, Sign up for my email newsletter at www.chemedsolutions.com/chemguide. In addition to weekly teacher toolkit tips, when you sign up, I have a few gifts just for you, including a high school chemistry course outline, a pacing guide, a unit checklist, and my personal teacher planner to keep yourself organized, less stressed, and enjoyed life. Happy sciencing!